Here we are with the quadratic equations, more advanced types of problems. In the previous video we did very simple basic quadratic equations. Here we are going to do a little bit more complicated versions. In the first problem, if you have instead of square higher powers of x, the power, if you have only two powers of x, which one of them is twice the other one, you can just treat them as quadratic equations and keep solving it like that. So here we have x to the power 6 and x cubed. So if you treat this as, for example, t, then this would have been t squared. So just keep solving as if it was a quadratic equation. So I'm going to factorize it as 8 and 1, because 8 times 1 is 8, 8 plus 1 is 9, x cubed. So if you factorize it, x cubed plus 8 multiplied by x cubed plus 1 is going to be factorization of this given equation. If you open the parentheses, you'll get x to the power 6, 9x cubed plus 8. Now you can solve these two parts separately. So x cubed plus 8 would be 0, and you could set x cubed plus 1 equals 0. So x cubed is negative 8 means that x is negative 2, and x cubed equals negative 1 means that x is negative 1. So we have two roots, negative 1 and negative 2, which are real roots of this 6th-degree equation. So these are real roots of this 6th-degree equation. However, since this is a 6th-degree polynomial, there are four more roots. Four more roots are complex roots. And since we are doing calculus with real variables, we don't need to find these four roots. So in some problems, the quadratic equation change of variables is not very obvious, but you may somehow see from the problem. For example, this problem, you can convert it to quadratic equation using change of variables. So if you open the parentheses here, it will become 4th-degree equations. There are potentially four roots of this equation. So I'm going to set this equal to t. So that means this is t minus 2, because x squared plus x minus 1 is t. If you do minus 3, it will be 2 less. So now the equation is going to be t squared plus t minus 2 equals 0. So now you can find t. So that was a change of variables. So you can factorize this. You can factorize this equation as t plus 2 and t minus 1. If you open the parentheses, you'll get the following equation. So the first t is negative 2, the second t is 1. So there are two options for t. So now we have to find x using the values of t, which means t was x squared plus x minus 1. So this could be equal to negative 2. X squared plus x minus 1 could be equal to 1. So there are two options. Solving both equations, x squared plus x minus. So here, if you add 2 to the both sides, you'll get 1 equals 0. This is here. The second one is much easier to solve because it's the same equation with this one. So x squared, just this different letter, right? So that means x is equal to negative 2 and x is equal to negative 1. So we have two of our four roots. Now let's solve this equation. So let's first find the discriminant, which is b squared minus 4ac. b is 1 squared minus 4 times 1 times 1, which gives you negative 3, which is a negative discriminant. So this part of the equation has no real roots. So I would say no real roots. So the other two roots are complex roots. We are not going to find them, but there are two real roots, which are negative 2 and negative 1. Here's another equation which can be simplified to a quadratic equation. So let's start with changing variables and setting this x squared minus 4x plus 1 to be equal to t. So that means if I add, so let me rewrite the equation in this form. So 3 over x squared minus 4x plus 1, and add x squared to the both sides. So just x squared minus 4x plus 3, which means this is t, and this one is t plus 2. So my new equation is 3 over t is equal to t plus 2. Multiply both sides by t and make it quadratic equation. So that's 3 is equal to t squared plus 2t, or t squared plus 2t minus 3 is 0. If you solve this equation, you can factorize it as t plus 3 and t minus 1. So the first t is negative 3, the second t is 1. So t could be negative 3 or 1. Since we know that t is x squared minus 4x plus 1, so we can set that equal to be 1 in the second case, or x squared minus 4x plus 1 is equal to negative 3. So there are two ways. So the first one looks like very simple one, so that's 0, and if you solve this equation, take out x minus, so there are two roots. So the roots are x could be 0 and x could be 4. Right, now let's solve this one. Add 3 to the both sides, so that gives you, if you add 3 here, that becomes 4, and this is 0. And this is a square, this is a perfect square, so x minus 2 square is 0. So that gives you taking the square roots and adding 2 to the both sides. This is a double root actually, so that's x3 and 4 are equal to 2. So we have 4 roots, 0, 0, 4, and 2, 2. So this is another very important type of problems. Here we can use Vieta's theorem. Vieta's theorem says that the product, when you have a quadratic equation in this form, the product of two numbers, the product of two roots is going to be q, and sum of two roots is going to be negative p. So this is Vieta's theorem. That's a very useful theorem, and in order to find this expression, we can do common denominators. Multiply this by x2, this is x1. So the common denominator is x1 multiplied by x2, and in the numerator we will have x2 plus x1. Now we know what is x1 multiplied x2 using Vieta's theorem, that's q. And we know what's x1 plus x2, that's minus p. So this expression in terms of p and q turns out to be equal to minus p over q. And the final problem in this set is the following. When the given equation has two distinct roots. When an equation has two distinct roots. So that's a very simple conclusion from quadratic formula. The equation has two distinct roots when the discriminant of the equation is greater than 0. So the discriminant is b squared minus 4ac. In this case, b is going to be this number, c is this, and this is obviously a. So let's do a plus 1 square minus 4 times a times c is negative 2. If you open the parentheses, a plus 1, a squared plus 2a plus 1, so this one is going to be plus 8a. So a squared plus 8a plus, so 8a plus 2a is 10a plus 1. So we want this equation, so we want this expression to be positive. So this is another interesting thing about quadratic equations. So this expression has to be positive. So in order to solve this quadratic equation, first we need to find its roots. So the roots of this quadratic expression is going to be, its discriminant is b squared, 10 squared minus 4 times 1 times 1, which is 96, and the roots a1 and a2 are going to be minus 10 plus minus root of 96 over 2. Or you can divide both sides and simplify it, negative 5 plus minus. If you divide 96 by 4, it's going to be 24, so it's going to be root of 24. Now if you draw the parabola of this equation, the roots are negative 5 minus root of 24 and negative 5 plus root of 24. And the parabola is going to be something like this, upwards parabola with two roots, because the leading coefficient is positive. So which means we wanted this expression to be positive, and then the result is this and this part. So when the equation has two distinct roots, the answer is when a is element of interval from negative infinity to this number, negative 5 root of 24, or from negative 5 plus root of 24 to positive infinity. So if the number a falls into this interval, then this equation will not have two distinct roots. So that was more advanced quadratic equation problems. In the upcoming videos, we are going to discuss quadratic inequalities in more details, so stay tuned.